Methods of persistence. So as far as persistence is concerned, again, I'm going to be focusing mostly on ways that malware can be persistent, but we'll talk a little bit more about a little beyond that. The most common method of persistence is you're going to need some sort of automatic execution. When your computer restarts or just at periodic various times, being able to execute that particular script, that malware, whatever it is, automatically. There's many different ways this can be done, especially, well, in any system, I guess, Windows and Linux. You can put keys in the registry. Both run and run once are two places where you can put stuff in the registry. I will pull that up over here. Let's go ahead and open up regedit. Of course, since this is modifying the registry, this did require them to have elevated access, but let's see. So this would be, the first place is HKey local machine, usually abbreviated HKLM. Software, then we have Microsoft, not Windows, Microsoft, then Windows. Current version, and then we should have run and run once. These are two places where looks like this is VBox tray, so VirtualBox. You can tell it's sort of virtualization software I'm running here. Looks like there is a security health systray.exe. There's a, I don't know what that is. There's a couple of things in these particular registry locations, but this is not the only place that you can find run and run once. There's also, in addition to HKey local machine, there's also HKey current user. There's also a run and run once here, and you can see those are actually, not quite the exact same thing. This user that I'm logged in as also has OneDrive that is automatically run. Let's go ahead. All right. Let's see. I was watching a walkthrough recently, and it looks like, I mean, there's other places in the registry where you can get automatic running. Obviously, you can't really know them all. Well, I guess you probably could, but if I went back to HKey local machine, and this would be software Microsoft network. Software Microsoft network. Okay, it's not in. Apparently, I don't have that particular key or that particular group. That was in software Microsoft Network Debug. Apparently, that runs at boot as well. They were using it to maintain persistence. It was creating a reverse shell that would dial back to their command and control so that they could continue maintaining access to that computer. So when I'm talking about maintaining persistence here, it's not just the how can the virus or the malware stick around. Well, malware in general. It's not just how can a virus stick around, but how can you pull up this reverse shell, get that execution again. As far as finding things in the registry, I don't know about you, but I kind of hate browsing through the registry in the built-in way that Microsoft has this set up. You can do reg dump, which will dump the entire contents of the registry into a text file. And then you can use something like grep to search through it if you're on a Linux machine or some sort of equivalent on Windows. Let's see, as far as scheduled tasks or as far as other ways you can do automatic execution, your standard task scheduler. This is definitely, if you're not familiar with it already, task scheduler here. This is pretty, it's pretty user friendly. You have, what's going on here? There we go. It is sorted into a bunch of categories, but you can see like BitLocker here. It looks like there is a couple of tasks scheduled to run. That task has not yet been run. That has not yet been run, whatever. This is, again, though, I don't know about you, but I hate searching through all the subfolders and trying to find something. So one way that you can kind of, again, I like kind of putting it in text file, going into command line. Well, I guess at is, or at is usually how people hear that people refer to that as. You could do, if I had like at file server 20, I don't know what, I had typos in here. You could say basically, oh, that's why, because I was typing this in and okay, whatever. You can kind of manually put stuff into, or you used to be able to manually use at to put stuff into your task scheduler, but anymore it's using SCH tasks. And you can do something like SCH tasks, create whatever you can do. You can query and give it XML format. One thing that's possible is to do something like this. Let me go ahead and pull up PowerShell again and type that in just to see what shows up. PowerShell SCH tasks /query /FO. I believe that's format or file output or whatever. I don't know exactly what the FO stands for, but CSV will output this as a CSV file. So you could then go ahead and pipe it into tasks.csv. And you can see now I have tasks.csv, which I could open up in whatever software I have that opens up CSV files. Oh, this is not letting me go up. And it looks like I don't have anything that will open up CSV files on this computer nicely. But if you have like Microsoft Excel or open up LibreOffice Calc or something like that, it'll do this in a spreadsheet format, which is a bit nicer to read. But again, the nice thing about this is then you can use your find. You could use grep on this. You could use various tools. Of course, you can use the graphical user interface of task scheduler. I just personally don't like that. I think it's slow and kind of cumbersome. Let's see, you can create a service. So that, again, methods of persistence here, creating a service within Windows. If you do sc.exe, well, I guess you don't need to do that .exe, you probably just sc, and then create. It will give you actually, oh, okay, nice. It walks you through the process of how to create a service. Oh, wait, set content. It appears to be, now whatever. So you can create a service in any case. Here's what you might type, create new service name. So you can call the service whatever you'd like. Then give your binary path. So in this case, you can see I'm saying it's c:\evil.ps1 or whatever file extension your executable is, your script or whatever it is, and start equals auto. So that means, you know, when your computer starts up, it'll just show up as one of your services. And so this is where, you know, you might be able to find it in here. But unfortunately, there's so many services, it's kind of easy to hide in the crowd. Let's see. Another method of execution that is sometimes used is abusing the fact that the way the Windows path variable works. If I pull up the path variable, give me a second. It's not, whatever. If I just type in, what is it? System variable, system environment and variables. When you go to execute something just in general, like if I was to go to PowerShell here, and I just typed in, you can see there is no notepad.exe in here, but if I was to type in notepad, it knows to look in specific directories. And the specific directories it looks in, I'm wondering if I have the, I can't remember exactly. Capitalized. I don't remember what it is. In any case, I'll just look in here again. Oh, environment variables, duh. Okay, so path. Oh, this is actually a really short path. Usually when you have several different things installed on your computer, there will be a number of other environment variables in here in this path. And this is the different places your computer is going to look to see if it can find, oh, here we go, system variables. This is the one I was looking for. So it will look, if I type in Notepad, it will first look in system root system 32 to see if there's a notepad in there. If there is, it would execute that. And then it'll look in system root and see if there's a notepad in there. And then it'll look in this one, and then this one, and then this one. So if you were somehow able to get a file in this system root system 32, so I guess that would be C:\Windows system 32. If you were to get a notepad.exe in there, when the actual notepad you're looking for would be just in system root, it would execute this one first. So this is a way for you to get the computer to execute your code instead of your program instead of the one that's actually intended. Let's see. So oftentimes those particular environment locations, these locations are going to be write protected, but it's not always going to be the case. Sometimes something might have been opened up and you have write protection on a directory, or you have somebody, or actually probably more likely, you have somebody or some program who comes in here, and when a program is installed, it will put there, it'll do new, and it'll say something like C:\my directory, my program. It'll put that, and it won't put it at the bottom to make it the last thing checked. It'll put it maybe at the top. So it would be the first place that was checked. And if that one's not write protected, well, that means that it can be abused. Let's see. The next, abusing spaces in file names. This kind of goes along, it feels very similar to abusing the path variable. But again, since Windows tries to be very flexible with allowing people to execute, there we go. Not letting people execute things without having quoted file names. So let me just look at this. We have program files. So typically, if you do tab completion with program files, you'll notice it does put quotes around this. If I did not do tab completion and I said cd space program files like this, oh, it didn't like it. Okay, well, yeah, okay, so apparently it didn't allow that that without quotes. In any case, Windows doesn't always enforce quotes around file names, and especially when you have a file name that was something like, let's see, I have an example here. If I had a file name that looked like this, C:\software space files \active space webcam space or \webcam.exe. Then if this program was told to execute, Windows would first look in this location. It would go up to there, because if this is an unquoted file name, it'll see the space and say, oh, okay, well, that's the end, possibly the end of that command. And so it'll look for a C:\software.exe first. And then it'll look in C:\software files \active.exe. It'll look for that one. And then it'll look for the full path. So if you were able to put some file, either C:\software, you probably wouldn't be able to write there because you can't write directly to the C directory by default. But you might be able to write in this C:\software files and put in active.exe in there. And that active.exe would be called before this webcam.exe. And if you wanted it to be really hidden, you would, when you're done with your execution here, this active.exe, you might call the webcam.exe. So there is no noticeable interruption in service from the user standpoint, but you are getting some additional execution that's happening. So there's lots of places to hide. So that's all kind of focusing on Windows. Of course, Linux is not really, it has lots of places to hide as well. You can do the cron tab. The cron table is your common place that you're going to have for Linux. So if I was to do cron tab -L, oh, there we go. Using an empty one. Okay, so by default, your cron table, this is just a bunch of things that will get executed automatically. On this computer, I didn't have any cron table set up, but if I was to do something in here, this is typically how these are organized. I guess they have an example right here: 0, 5, *, 1, and then some command. What these individual columns mean, you can see right here, M, that's minute. So this one would be executed right on the hour, so at minute 0. At 5 a.m., it looks like. So it'd be executed directly at 5 a.m. If this was like 10:05, this would be at 5:10 a.m. The next two columns, this is day of the month and month. So if you wanted to execute something, say on the first day of every month, you would do a 1 here. If you wanted *, this is going to be on every single day. If you only wanted to execute on February or only in July or something like that, you might specify a particular month instead of a *. And then the day of the week, this one can be used if you want it to only execute on Sundays or only on Saturdays or something like that. So this is incredibly handy if you want periodic something to periodically execute in Linux, and then you just have your command here. But this, can be used to, like I said, run things automatically. If you do cron tab -L, that will list out the current jobs. If you just say, oops, I'm not in Vim. Or am I? Oh yeah, I am. If you do cron tab -E, this will edit it, and you can see there was an interactive editor there. It probably will be Nano by default, or you can choose if it's not chosen yet. I was in Vim. You can do cron tab, I believe it's -R to flush that. I can't remember offhand. Whatever, I never use -R. I always go and manually edit it because, yeah, so -R will cause the current cron tab to be removed. So you can flush your particular cron tab. But yeah, I personally would go and edit it. Each user, so one of the difficulties here is that each user has its own cron table. So if you're logged in as the administrator, you can have things executed periodically. And in order to see what is executed periodically by a different user, you would have to look elsewhere. There is an at command in Linux as well that will basically, if you want something to run at a specific time, at 500 seconds from now, do this thing. You can daemonize something. This would be very similar to creating a service in Windows. You can create a daemon in Linux. So for instance, if you put a shell in the etc init.d, so cd init.d, etc first, init.d, you'll notice there's all sorts of files in here. And if we do the actual, what is it? etc rc ls rc star, you can see there are various things that are run. rc0, rc1.d, rc2.d, rc3.d. There is a specific order as far as when in the boot sequence these are called. But you would typically, I think, put something in rc4 or rc5 usually if you're wanting it to be daemonized. I haven't really messed around with that. Or if you just add an ampersand to a command, technically it's daemonized there as well, although that's not automatic execution. As far as finding out what is currently running on a Linux system, PS AUX. So PS is showing all the current processes. That's what PS would be. And I usually use AUX. A is, I believe, for show all users. U is to show the specific user. And X is, I can't remember offhand what X is. I think so it shows the PID. I think. Yeah. No, PID shows up normally. Whatever. I don't remember exactly what X stands for, what it does, but PSAUX is a great way to show all running processes. And then you'd want to grep it for, I don't know, see if there's any Python running. It looks like I do have some Python running on this system. It looks like user bin, whatever. And you can kind of trace down to see what is running that way. Also in Linux, you can use top or htop. Htop is a little bit nicer graphical interface, but they show the same sort of information. This will show you process or all your different CPUs and how much memory you have and how much is currently utilized. And then you can scroll through here and see what is currently being, what processes are running currently. Q to get out of that. Yeah, there's all sorts of different ways to investigate what's currently running. You can see what files are currently open with LSOF. LSOF will, oops, I probably shouldn't run it on everything though. Let's do LSOF. Let's just show users for Jeff. And you can specify if you want it to be related to a specific process. Yeah. Let's choose a process here. Let's choose PS, UX. Let's look to see what Firefox is running. Grep. One of the processes for Firefox is 10580. So if I was to do this and do all process 10580, this will show any open files related to that particular process. LSOF, that's list all open files. Okay, well, there's not much there. LSOF-U root. This will show just things that are run with, that are actually run as root. And it looks like I have permission denied on here. So you probably have to sudo that. Let's see, other methods of, so this is, again, primarily persistence of malware. If you wanted to look at persistence of like an ABT, you're going to want to look for backdoors. Very common backdoor is to just give, for them to give themselves an account. You know, maybe add themselves to the administrators group or something like that. In which case they wouldn't have to log in with the administrator account. You could change the password on that one and they would still have access because they have their own account. So you might, you know, you definitely want to check to see what users there are on the system, if anything has been added recently. One thing that's a bit more niche, but I don't know, I've seen in a couple of like capture the flags, is this idea of port knocking. So port knocking isn't just having a shell open all the time, but instead, if you ping first port 243 and then you ping port 1067 and then you ping, you ping in a specific order to different ports. Well, not pinging, but if you send a packet to these various ports in a specific order, then it'll trigger this particular computer to then open up a normal bind shell, so you can log in. But it doesn't have to be anything nearly that fancy. You could just have a typical reverse shell as part of a Trojan. You know, you go and download the latest in this cool free game, and every time you run that game, it reaches out a reverse shell to see if the controlling server is listening, and if it does, guess what? They have shell access to your computer. As far as covering the tracks, things you want to look for is if anything. Well, typically they're going to want to erase, modify, or disable evidence. So when you're talking Windows, you if you can find out if there's any modified logs. It is important typically if you have a seam, you typically want the seam to be separate from Windows itself. So that's why you do typically see it as a physically separate computer, because if somebody is able to compromise that Windows system, you don't want them erasing their own tracks. So so what you might do is you might check to see if you have a seam, if there's any changes, if there's any differences between the Windows logs and what the seam is showing. That might actually be a good signal. Linux, of course, has logs as well. The .bash history, .bash_history, that's just a file in the home. You'll notice, let me do, yeah, .bash_history. You can see there is, it'll show, I just showed the last few commands, but you can see there's, you can see a few commands that I've run in bash here. So this is something that if you're investigating a system and you notice the bash history is empty, then that's a pretty good signal that, hey, somebody may have cleared the history. Although, of course, it is possible this is just a text file. Somebody could go in and just remove their commands. So that's not, that's not as clear a signal as it could be, but it's one more place you can look. /var log, of course, you've already seen some of this stuff. Auth.log within there will show who's logged in, but again, this is subject to all the same constraints. These can all be modified if they're on the system that's compromised. And you can't really rely on the last modification time as a firm indication that something is right or wrong, because time stomping, this is the act of changing the file, the last access time. It doesn't have to be specifically when it's accessed. You can say, hey, change the time to this other value. And tools, Meterpreter, that was the tool I was trying to remember earlier. Meterpreter actually has a built-in tool for doing time stopping so that they can hide their presence. And if you do discover somebody in your system, you do want to be careful about how you deal with things. You don't want to just shut off their backdoor right away, because it is very common for them to have multiple backdoors and multiple means of persistence. And if you shut off one of the backdoors and you don't get the other one, well, they know the gig is almost up, so they're going to escalate. That might be, they might have been trying to, up until this point, they might have been trying to be quiet and to just slowly look around. And if they notice that they're being discovered, they'll flip a kill switch, which will run some crypto malware and encrypt your system, or something along those lines. So you do want to make sure that even in incident response, that you're not making a ton of noise to, you're not letting a potential intruder know that they've been discovered. All right, that is enough